So welcome back. Now let's talk about the standard template library, which is a very useful feature for C++ programmers. We'll talk about the standard template library and look at a few STL containers in this video. So an overview of STL is it is the answer to the limited functionality in C++. So programming languages typically have very basic functionality inbuilt to them because that's the kind of stuff that every programmer needs. It has primitive data types, it has arrays, it has structures, it has classes, but sophisticated data structures are available separately. So you can say something like batteries not included. Why is that? The reason is that if we include all that sophisticated functionality as part of the standard programming language, the compiler becomes too complex, too bloated, and that is not desirable. So to overcome that limitation, the C++ programming language provides a library that has four major components. One is containers, the other is algorithms, and then there are iterators and then functors. We won't talk about functors in this course, but these are all very, very efficiently implemented and very, very flexible. And the reason is that they are based on template classes. And we already looked at template classes. Uh, as far as the STL containers are concerned, these are nothing but data structures to store and retrieve data. The data can be simple data types, built-in data types, or they could be structures, or they could be objects of classes that you define yourself. And under the hood, they are implemented as template classes. All you need to do is to include the corresponding header file and use the container. Now, let's see what kind of containers STL provides. So the STL containers provides a class of containers which can be called sequence containers. And then there are containers that are container adapters. And then there are associative containers. As far as associative containers are concerned, these come in two types. One is unordered and the other is ordered. We'll take a look at what exactly this means later. But as far as sequence containers are concerned, they store one element after the other. That's where the name sequence comes from. As far as container adapters are concerned, these wrap the access semantics over other containers. Meaning, if you want to access data in specific order, for example, rather than the order in which the elements are stored, then that can be applied using container adapters. And as far as associative containers are concerned, these allow accessing elements by keys rather than the index or the location of the element. The ordered associative containers maintain the elements in a sorted order. So if you want the elements to be available in ascending or descending order, this is very, very useful. But if that order is not important to you, then you can certainly use the unordered associative containers. So let's look at the sequence containers first. The examples of sequence containers in STL container library are array, vector, double-ended queue or deck, forward list, and list. So each of these container classes is used for a different purpose. So recall C++ dynamic arrays. So what are some of the challenges that you face when you work with dynamic arrays? Well, obviously you have to do the memory management yourself. You need to implement common operators yourself. There is no bounds checking by the compiler or the runtime, so you have that risk. And when you copy a dynamic array, a shallow copy is created, which is often not desirable. Start with the vector container. These are essentially arrays that can change in size, just like the dynamically allocated array that we've been implementing over and over. And these are best for cases where you need efficient random access to data, and the inserts or deletes are always at the end of the array. So let's look at a code example to explore vectors. So let's see how we can use the vector STL container. The first thing we need to do is to include the vector header. Now let's see how we can create an empty vector and then store values inside it and then retrieve them. So I've defined a function named empty init. In that function, what I'm doing is I'm creating a new vector container object. Std colon colon vector is the class name. And this here is the template parameter. What type of vector do I want to create? I want to create a vector that can store integers. And the name of that vector or object is numbers. Now what I can do, this particular object is empty at this point. Now I can call the pushback function to store values at the end of the current values in the vector that was stored already. It's initially empty, so the first value that gets stored in it is 1. Then I store a 2 in it, and then followed by that I store a 3. And then I have a cout statement that says what I'm about to do is to display the numbers after they've been pushed into the array. And this is a modern C++ feature. It is called a range-based for loop. You don't see any i's or j's initialized over here. You don't see any terminating conditions. You don't see an increment operator. This is a modern C++ for loop called a range-based for loop, which you can use with the STL iterators, for example. And as the in this range-based for loop, I specify the name of the container object, which is numbers. And before the colon operator, I specify a variable name and a data type. So this variable name is going to get the values, successive element values from this container. So first time through the loop, it is going to have the value of the first element in numbers. Second iteration through the for loop, it's going to have the value of the second number in this array or vector numbers, and then so on. And now since I know that the type of every element in this array is int, I've declared num to be of type int. By the way, we could also set this to auto and be very, very modern C++ and let the compiler figure out what the type of this argument is. And then what I do is I see out the value from the vector over and over. All the values are displayed, and then a new line is displayed. Let me scroll down to the main function. And in the main function, I have a cout, a message being displayed that we are going to create an empty vector and then going to add elements to it. And then I call that empty init function. And then I have a line being displayed on the terminal so that we know that this function's execution has completed. Let's switch to the terminal, compile this program and run it. Program compiles fine. And when I run it, I see this message displayed from the main function. And then I see this message that was displayed from the init function, numbers after pushback. And since we had added 1, 2, and 3 to the vector, those are displayed on the screen. And then we had this line being displayed to separate out the output from this program. So fantastic. So let's see what else we can do with vectors. So I've uncommented some more of the main function, and this particular portion calls a function named sizedInit, which I've defined above the main function. And what it does is it creates a vector with a specific initial size and specific initial values. So let's see how we can do that. Over here, I am initializing a variable named size to 5. So I want a vector that is initially of size 5, and the init value variable is being set to 10. And these parameters I am passing to this function. Let's scroll up and look at this function. So here's the sized init function. It accepts those two arguments, and we're also using a default parameter value for the second parameter. And here's our instantiation of the vector. Here we are creating a vector object. And for the template parameter, I'm passing int because we want to store integers in this vector. The vector's name itself is scores. And these two parameter values, 5 and 10, indicate the initial size of the vector and the initial value for all the elements in the array. So we should actually be setting or passing the value of the variable size and init value as these parameters. So the vector class has many, many constructors. One of those constructors is one that accepts as the first parameter the initial size of the vector, and the second parameter accepts the initial value for all the elements. Let's see what happens if we try to see out the values from this vector scores without actually storing anything in it explicitly using pushback or something else. So I have a cout that says here's the initialized scores, and there's a for loop, an old traditional for loop that goes from I equals 0 to the value of scores dot size. So size is a vector class member function that returns the actual number of elements stored in that vector. And I'm incrementing I in every iteration of the for loop, and the cout statement displays the elements from the vector just as if it were an array using the indexing operator, which is great. And then at the end, I uh, insert a new line to the output. So let's switch to the console, compile this program, and see what happens. So the program compiles fine. And when we run it, we obviously have the init function output on the screen. And then we create a vector with specific initial size and values. And over here, you see that the initial values in the vector, there are 5 of them, and each of them is 10 because we had created the vector to be that way on this line number 18 in sized init. So let's uncomment some more of the main function and see what else we can do with vectors. Over here, I have uncommented a remove vector function call. And what this will do is it will create a vector of a specific size and then remove the last element from the vector. So often you might find yourself needing to remove the last element from a vector. How do you do it? Let's see. Let's scroll back to the remove vector function. This over here is that function. I am creating a vector using the same syntax as we did for the previous function. And we are saying that I want a vector of initial size 10 and all of the elements should have the value 10. And then I'm calling this function pop back on this object named scores. This is a vector class member function. And what it does is it removes the last element from the vector. Now, if I were to iterate over the scores array and display each of its elements, I should see not 5, but 4 elements because one of them has been removed from the vector. Let's see what happens if we compile and run this program. I compile the program, I run it, and then sure enough, I see this output on the screen, creating a vector of a specific size and then removing its element. And then instead of 5 elements, we see 4 elements displayed on the screen. Fantastic. So let's continue the exploration. Let's see some other cool things we can do with a vector. How can we resize a vector? Let's uncomment this. In this example, we're going to create a vector and then we're going to resize it. I'm calling a function named resize vector. So let's scroll up and see the implementation of that function. Here it is. Over here, once again, I am creating a vector which is of size 5 initially, and all of the elements in the 5 size vector are set to the value 10. And then I am calling this resize method of the vector class on the object named scores. So now the scores vector will be resized to 10 elements. And this second parameter specifies the value that the newly inserted, newly added elements, what will those values be initialized to? So the first 5 elements should have the value 10, but now since you are increasing the size to 10, 5 new elements should be inserted and their initial values should be 100. So now we should see 5 tens followed by 5 hundreds on the screen if we were to display those numbers on the screen, just as we are doing in this example. So let's again switch to the terminal. So let's switch over to the terminal, compile the program and run it. And sure enough, you see creating a vector, then resizing it, and numbers after resizing are, you have 5 tens followed by 5 hundreds. So let's continue our exploration. I'll come to the this example of iterators later on, but right now let's uncomment this part of the code and see what it does. I'm calling a function named clear vector, and what it does is it clears all the values stored inside the vector. So let's scroll up and see what the clear vector function looks like. Uh, just like before, you create a new vector object of integers of size 5 and you store an initial value of 10 inside all of those values. You display all of the numbers that you got there, and then you make a cout statement once again, saying that you're going to clear the vector, and then you call the clear member function of the vector class on this object numbers. And once that has been done, you again just try to display all the numbers in that vector, followed by a new line. Now let's see what happens when we compile and run this program. So back to our terminal, compile the program, and I run it. And sure enough, you see that you create a vector and display the 5 tens stored in it, but